this is King of Review. Here we have the sum of three separate logs. We have to simplify this. Now there is a property of logs that lets us combine logs that are added together. However, that property requires that all three logs have the same base. Since that is not true here, let's examine each log separately. Let's start with the log base 5 of 1/5. It would be nice if we could turn this fraction into something that's just a power of 5, because logs are all about powers of the base, which in this case is 5. And we can certainly do that, because any number to the -1 power is just 1 over that number. So we can rewrite 1/5 as 5 to the -1 power. Now, let's set this equal to x, just so that it can be equal to something. We're going to use a property of logs to solve all three of these different logs, and the best way to solve logs is to rewrite them in exponential form. If we have the log base b of some number a, and that's equal to some number c, we can write this equivalently as b to the c power equals a. In our log on the left, that means 5 to the x equals 5 to the -1, which means, since 5 and 5 match, x has to match the other exponent, -1. Let's look at the second log, log base 3 of 27. 27 is a power of 3. In fact, it's 3 to the 3rd power. So if we set this equal to some number y, we can use the same property from the right to say 3 to the y equals 3 to the 3rd, and thus y must be equal to 3, the other exponent. For the final log, we have the log base 2 of 1/4, and we'd like to write 1/4 as a power of 2. Well, the 4 is easy enough. The 4 is just 2 squared, and since 2 squared is in the denominator, we can use a similar fact from 1/5 and rewrite this as the log base 2 of 2 to the -2 power. If we set this equal to some number z and apply our property on the right, we get 2 to the z equals 2 to the -2, which means z must be -2. Therefore, our three logs added together are just the sum of x, y, and z. -1 plus 3 plus -2, and this adds up to 0. So there's our answer. Thanks for watching.